welcome everyone. We got a great meeting today. We're going to be hearing from Alaka'i in Boston about their hydrogen fuel cell powered hexacopter, and it's fantastic the work they've been doing. Rather quietly, but they have been cranking along and have an amazing product and amazing team. So it's going to be fun to hear from them. Before we hand the reins over to them and hear their great presentation, I usually like to offer an opportunity to any new members that maybe it's your first time, that you don't have to, but if you wanted to do an introduction yourself, where you are geographically and where you are in terms of school, career, or interests, we'd love to hear from you right now.
I'll go first. This is my first time. My name's Pat Host. I'm a freelance news reporter. I spent most of my career writing about military, aviation, and space technologies at Janes and Defense Daily. And in the last year or so, I've been writing about commercial rotorcraft and eVTOLs for publications like Aerospace America, Vertical, Vertiflight, and Avionics International. So thanks for having me.
Really glad you're here. Thanks for being here. Who else is new that would like to do an intro?
Happy to go, Andrew. Yeah, so I'm Eric Schiff. I've spent 25 plus years in technology here in Silicon Valley in the Bay Area. So 25 plus years in technology, looking to transfer into the advanced air mobility industry, and actually I'm working on a white paper and looking forward to hearing what Alaka'i has to say, and if time permits afterwards, maybe talking to some of the team members from Alaka'i.
Outstanding. Welcome, Eric. Thanks for being here.
Shall I jump? I'll jump in now. So my name's Hazel.
Hazel, please do.
Yeah, I live in the UK in a normally sleepy town called Cheltenham, but it's very busy this week. So we have a very famous horse race on. The Queen and co were actually here yesterday. In terms of career, I have a normal day job. I work for Collins Aerospace in a BD and sales capacity, but that's not why I'm here. I'm here. I've recently finished a postgraduate program at Oxford University in Strategy and Innovation, and have now started on a doctoral program with Toulouse Business School. And the area of the research is going to be focused on the commercial aspects of the sort of eVTOL industry as it's kind of shaping up. So that's why this is of particular interest to me at the minute.
Perfect.
Okay.
Perfect. Welcome.
Hey, Andy, this is Jeremy Hayes. I know we've worked together years ago, but I'm for those who don't know me, I live in Dallas, Texas. I also work in a sales capacity for a fractional ownership company called AirShare. I've also worked for Marty Aerospace on the Rotorcraft side, as well as the fractional side when they own FlexJet. So happy to learn more and be a part of this group to hear what's going on with the future of aviation.
Thanks for being here, Jeremy. You were our 300th member, so if I had some balloons to release right now, I would.
Well, thank you, Andy. Happy to be here.
Yeah, thanks for joining. Glad you're here.
Hey, Andy, it's
Anyone
Mike
else?
Francis. Good to see you. Thanks for including me. I work for Silicon Valley Bank and their private bank and lead the private jet finance product, and a lot of intersections with where our industry is going in the eVTOL industry. So curious to learn more about Alaka'i and what's coming next.
Outstanding. They're your neighbors in Boston area, and I'm glad you're here, Mike.
Thank you.
Anyone else that would like to do an intro?
Me. Hello, I'm Stan. I'm software engineer in the past and currently building a company related to maintenance and repairs for aircrafts.
Excellent. Stan, thanks for being here. And Josh, I think you were going to introduce yourself.
I was. Speaking of Boston, hi everyone. I'm Josh Elvander. I'm the Senior Vice President of Engineering at Maglev Aero. We're developing a new propulsion concept for eVTOL and unmanned systems. Very low acoustic high efficiency, electric driven system, but we don't care where the electrons come from. Could be a battery, generator, fuel cell, you name it. So hence the interest. Met Andrew at the TVF show back in early February, I think.
Josh, great to see you again, and thanks for being here. Anyone else?
Yeah, this is Ruben Steffen here from Skytrack. So my first time here coming on, so thank you. I'm very curious to be part of this group, and Skytrack does connectivity using Iridium systems. We do C2 communications and connectivity for passengers.
Excellent. Glad you're here, Ruben.
Thank you.
And any other intros before we move on to some discussion about hydrogen?
Hey, Andy, can you hear me? Sorry, this is
Yes.
Tao from Denso. So I joined a bit late. So I'm working on primarily on the electrical propulsion system for business strategy development. I was also engineer for electrical drive systems in the past at multiple different locations. I'm very happy to join this conversation with other members here.
Very glad you're here.
Yeah, thank you. Yeah.
We're going to talk about events in a second, but before we pivot to that, any other introductions from new folks? So we're sponsored by the Vertical Flight Society, and so I wanted to mention that we've got an event coming up the beginning of, the beginning of May 7th to 9th is Forum 80, and that's going to be in Montreal, Quebec. And a couple people alluded to the fact that we just had a Vertical Flight Society event, the eVTOL Symposium out in the Silicon Valley a couple weeks ago. And that was focused on our space that we're working on here. And it's important to remember Vertical Flight Society encompasses, their focus is all of vertical flight, whether it's emerging technologies like we're working on here in the Transformative Vertical Flight Group, or traditional technologies like conventional helicopters and things like that. So that forum is focused on a little bit of everything, certainly emerging technologies, but a lot of it is about everything that's going on in the entire space. If you're interested in learning more, go to VTOL.org, but it's a great event. We had it here in Florida last year. I went and I thoroughly enjoyed it, so I recommend it if you think it might be interesting. Are there any other events on your horizons that you'd recommend, or that you've been to recently that you wanted to say a few words about?
Andy, it's Ken Swartz. I'm a board member of Vertical Flight Society and senior editor of Vertiflight magazine, and also eVTOL News. Would also want to mention the Vertical Flight Society's Electric Aircraft Symposium, which is coming up again this year on the weekend before EAA AirVenture Oshkosh. We hold this event at the Alumni Center at the University of Wisconsin Oshkosh. It was an event that started in 2007 by the Cafe Foundation in the Silicon Valley, California area, and transitioned to Oshkosh back in about 2017. VFS and Cafe partnered at that point, collaborated on this event, and during COVID, VFS provided a lot of the support to go virtual, and we went up to about 600, 700 attendees as a virtual event. So we're back in Oshkosh. It's a Saturday and Sunday event, the weekend before Oshkosh when things get very busy. We had over 250 attendees, both in person and virtual, and we're working on a program both looking for speakers and welcoming attendees. If you're looking at Oshkosh as a destination, or you've never been there and you need a extra reason to go, and this event covers both vertical flight and conventional flight, and that's, I guess, where I started to jump in that VFS says, with the common systems architecture underlying a lot of eVTOL and eCTOL activity, propulsion systems and technology. This is an event that brings together sort of the whole spectrum of the industry, from personal aircraft right through to advanced rotorcraft and regional aircraft as well.
Outstanding, Ken. I'm glad you brought that up, and I see that our that Dan was kind enough to drop the link to that event as well as the forum in the meeting chat. So grab those links while we're still in the meeting. And I can say, Ken, that I went to the Electric Aircraft Symposium last year. It was fantastic, really well run event. And it's also kind of nice if you've never been to Oshkosh. It's aviation's Woodstock. You've just got a little bit of everything there. And it's nice that this event is the preceding weekend, because then instead of flying in the same day that everybody else is on Saturday or Sunday, you can fly into Chicago or Green Bay on Friday when there's less traffic and lower airfares, and then attend the event Saturday, Sunday, and then just jump right into Oshkosh. It's called EAA Air Venture is the main event there. And boy, it's just incredible. If you haven't been before, and if you have, you know what I'm talking about. So worth attending both of those. Thanks, Ken. Any other events that should be on our radar or that have happened that there's some stories to tell about?
Yeah, Andy. Sorry, after you, Johnny.
Okay. Oh, just a quick reminder that next week will be the Transformative Vertical Flight Working Group meeting on public services. The next week's topic mainly will be on the eVTOL for first responders. It will be interesting discussion. And follow that, we also probably going to cover some of the roundtable topics and perhaps the topics moving forward. What's the working group's focuses will be. So please join me, and we will be sending out the invite to everyone shortly. Thank you.
Outstanding. And for those that are new, you should know that Johnny Du leads the working group and has been for years. The Vertical Flight Society working group that's focused on public safety, so police, fire, rescue, and they've done some amazing work. Have some excellent speakers. Johnny and his team have done a white paper published by NASA that's worth a read if you're interested in that space. And he and his team are a great resource and have a lot of knowledge and bring a lot to the table in that group. So it's I always attend, and I hope you do too. It's really worthwhile. Thanks, Johnny. And Alistair.
Yeah, it may interest this group to know that there's a brand new conference debuting next week in Europe. It's in Venice on Wednesday, and it's called Future Opportunities for Seaplanes and Amphibious Aviation. But there are a lot of concepts in the amphibious space that are using hydrogen and electric powertrains, and they're all getting together next week, I think for the first time. So I'm happy to report back. I'm going to be there.
Outstanding. That sounds like a lot of fun. Good. Thanks for letting us know about that one.
Is there a link for that meeting?
I'll post it in the chat.
Okay, thank you.
Take some pictures for the rest of us that don't go. Would love to hear a report next month if you're able. And Alistair's dropped the notes in the chat, and Kirk McKenzie was kind enough to also include notes in the chat about a huge public safety event. More than 30,000 first responders attend this one. So if you're interested in that space, that's his wheelhouse. And I've looked into that event. I'm not going to be able to go this year, but I absolutely want to go. So take a look at that link as well. Anything else before we chat about hydrogen and Alaka'i a little bit? All right, I'm gonna work on some colossal screen sharing blunders that you'll be able to be a part of. You'll be able to say, I was there when the train wreck occurred. Let's see. Okay, can anybody see my hydrogen is screen?
Yes.
Yeah.
Okay, perfect. So just some quick notes on hydrogen. It's the most abundant element in the universe, and it's of course part of what makes up water in our oceans. And when it's separated from oxygen, it's a fantastic store of energy, like a liquid or gaseous battery. And then we can recombine it with hydrogen to create electricity. And that's done through fuel cells. When we do that, we're just emitting two things: some heat and some water. That's it. There's no carbon in the process. And it's something that's it's not a new thing by any stretch. There's already more than 60 vehicle refueling stations today available to the public in California. And I'll talk some more about its existing prevalence in a minute. The other interesting thing is that it's the lightest element. It's even lighter than helium. It's extremely light. So if we did have a leak, and that happens in today's conventional aircraft, you know, I'm a pilot, and you know, there's sometimes you'll see a wing dripping. It occurs. When that happens with hydrogen, because it's the lightest element, it just vents up. It just goes away into the atmosphere, and that's a really nice inherent safety feature. There's some other interesting things about hydrogen versus batteries and you know, existing jet fuel, things like that. Because it's the lightest element, as we scale an aircraft up, our weight doesn't scale. The only thing that we need to do is have a slightly bigger tank, and the tanks today are extraordinarily light. So we don't have a whole lot of extra weight when we have a larger tank to give us longer range. And that's very different than when we think about a conventional aircraft with jet fuel. Hydrogen has, by weight, has 3 times the energy as gasoline or jet fuel. I think let that sink in. That's a big deal. 3 times energy by weight. When we're talking about aircraft, that's a huge advantage. And of course, when we scale batteries are very heavy, and that's the enemy of lift when we're trying to scale and we're having to increase weight dramatically in an aircraft. It does make it difficult to scale, and it does make it so that we, at least with today's existing technology and batteries, we hit some barriers rather quickly. Works for smaller aircraft, but when we want to think about longer ranges or larger aircraft, hydrogen can be a fantastic solution. And then similarly, you know, this graph kind of shows us where we're at with volume. Same thing here. We have to scale up the volume when we are talking about more range, which is our we can see at the bottom. We've got to have more hydrogen, of course, so that takes up more volume, but nowhere near the increase in volume we'd have to have with batteries. And then I wanted to talk about that. I wanted to circle back to that safety issue, and I was going to show you a quick video that kind of, this is like 15, 20 years old. You'll be able to see, but it shows the difference between current fuels and potential future fuels.
With all these safety systems in place, it's extremely unlikely that these vehicles would leak much fuel, and even less likely that a leak would result in fire. The controlled simulation you are about to see shows the result of the failure of one system, the pressure relief device. Though experience with natural gas has shown that a failure of the pressure relief device is extremely rare, the results of such a failure would appear like this. In this demonstration, fuel was purposely leaked and ignited by an electric spark, in both a car fueled with hydrogen and a car fueled with gasoline. The hydrogen tank empties in less than 2 minutes, and the flame goes out with virtually no damage to the vehicle. Inside the rear window, the temperature rose only 13 degrees Fahrenheit, and at the steering wheel, the temperature barely went up at all. The reality is that safe design makes this kind of an event highly unlikely for any kind of vehicle.
Okay, could we see and hear that okay? Yeah, okay, good. Good. All right. So I want to look at some Department of Energy information that they've shared. And let's see if I can, oh boy. I've got a lot of screens open here. Okay, let's see. Okay, can you see a big circle? U.S. energy related CO2? Yes. Okay, outstanding. So this gives us kind of an overview of where we're at, or where we've been at over the past few years with respect to carbon dioxide emissions. And if we look at transportation, is about 1/3 overall, and air is at 4%, depending on who you ask. here's the problem. We have solutions in place for trucks and cars and shipping and things like that, and we're executing on those now with the electrification of aviation. But electrification of ground transportation, but aviation is more of a challenge. And so what if we don't take action quickly and look at alternative technologies to lithium ion batteries, we're going to be looking at an air component of pollution that's sneaking up from 4, 5, 10% and beyond. So we need companies to be paying attention to this, and they are. And it's an exciting opportunity to decarbonize aviation. And I'm glad that companies like Alaka'i are paying attention to it. When we think about where is this hydrogen going to come from, I wanted to look at this screen. This one on the right gives us a snapshot, and this is, mind you, this is 2 years ago. This is 2022, of where we're at today with hydrogen utilization. And if we haven't paid any attention to it, and I think a lot of us haven't, if we're not in the space, we might not realize how much is already going on in terms of hydrogen utilization. There is more than 50,000 forklifts that are using hydrogen today. Think about that. That's just a massive number. It can be a bit surprising that there'd be 500. There's more than 50,000. More than 80 hydrogen fuel cell buses, and there's now more than 60 retail refueling stations. And there's multiple car companies, vehicle companies that are making hydrogen fuel cell cars. As of 2 years ago, more than 13,000. Those are some pretty big numbers. So I just, what this says to me is hydrogen is not a future fuel. It's an existing and fuel of yesterday. It's something that's in its continuum and growing fast. So it's an exciting situation. Now, where's the hydrogen going to come from? This is what I was thinking about before. This is a 2021 snapshot of electrolyzer power capacity. Electrolyzers are what we can use to generate that hydrogen and where it can come from, and by using water and electricity to separate hydrogen and oxygen. That's how we can isolate hydrogen, and we can do that using green energies. This is where we were at in 2021, and this is where we were at in 2022. Now, I don't have the numbers for last year, but it's growing at a very fast clip, which is a wonderful thing. Okay, so that was what I wanted to share with, just sort of to give us a snapshot of where we're at with hydrogen, what it means, and why it's important. And that's all the lead up to our presenters today from a company called Alaka'i in Boston. And they've just made a really solid video overview of the organization and what they're up to. And what I'll do is I'll share that, and then that's about 3 minutes. Excellent video. And then I'll introduce our professionals from Alaka'i and let them take it away and tell us the real story. So let me see if I can go to the video, get that spooled up. All right, here we go.
What I saw was the future of aviation.
The first day, I still remember, we went into the hangar and I saw the ultralight vehicle. It was amazing to look at.
The car came around, and it's this totally new technology. And in the early days, it was difficult, but then research and development happens because it's so much better than what existed before. Aviation changed long-distance travel. We're putting both together. It's the on-demand, point-to-point benefits of a car with the safety, reliability, and distance travel of aviation. The goal of the company is to have a 1,000-pound payload, fly for 4 hours at least 100 miles an hour. So about 400-mile range and fit 5 people. Now, we decided to do that with hydrogen.
The carbon footprint of the old jet engines was huge. Now with hydrogen, there is no footprint.
Hydrogen is very eco-friendly, and it's one of the most abundant resources that we have. So the more sustainable, the better for our environment.
You take hydrogen and add it to oxygen, you get water and energy. We use the electrical energy created in that, expel the water. That's all it is.
It makes a lot of sense to use hydrogen on something like an airship because it's very light compared to more conventional fuels.
There are several companies working on eVTOLs. We are the only one working on the hydrogen aspect, and that is the key differentiator.
We're the first electric vertical takeoff and landing aircraft that's flown on hydrogen ever. It's important for the environment. To get carbon out of aviation, it's going to require hydrogen, and we're doing it.
The dream is to sell for air taxi, air cargo, med flight, disaster relief, and there are military applications as well. We're not just urban air mobility, we're connecting cities together.
We want this vehicle to really be multi-use. We want it to be able to be used for city-to-city transport. So if I'm living in Boston, I can take an hour taxi to New York City.
Our interior is reconfigurable to whatever mission the customer that bought the vehicle wants.
Working with point-to-point relocation of people, supplies, healthcare, being able to help patients and medical staff get to locations.
The ability to take off or land from vertiport, from an empty parking lot, opens up the markets and the usability of the vehicle itself.
Everything we do for the passengers, the equipment, and the environment, we're always thinking about safety.
We have 6 rotors, and the reason for that is redundancy and reliability to make the product safe.
That's kind of what our advantage is in being distributed propulsion. We can lose a complete rotor and still fly on the remaining rotors.
Also, we have a parachute on the vehicle so that the vehicle will coast down and the people will land on the ground and be able to walk away. We have all the pieces at Alaka'i already in motion, so everything is being worked on, including the FAA. We have an active certification program with the FAA. We meet with them regularly. We provide them data, documents, reviews, those types of things. They provide feedback, and we meet every other week with the FAA. That's pushing forward.
It's a very collaborative effort where we're working together with the FAA. It really is, how do we deliver this technology in the safest way possible?
Excellent video. I love that. That's fantastic. Okay, so I'm gonna introduce our speakers, and I'll ask everybody that isn't a speaker to go ahead and mute, please, so we don't hear any dogs or cats meowing or barking in the background. And to introduce our speakers, I'll start with Tim Quaglieri. He's the head of finance of Alaka'i. He's focused on Alaka'i's financial management. He's got 20 years of experience with companies from startups to publicly traded companies. He's led finance teams domestically and internationally as well. And then there's Jeff Coulter. He's the head of systems integration. He's an aerospace engineer. He's focused on safety and certification of new and novel aircraft systems on board Skai. And finally, Andrew Tait. He's a business analyst at Alaka'i. He's an environmental economist. He's engaged in modeling Skai's cost of ownership savings for multiple business operations scenarios. Those are our 3 speakers today. And with that, gentlemen, the floor is yours. Please take it away.
Thank you, Andy, very much. Thank you, everybody, for joining us and learning a little bit about Alaka'i today. Like Andy, I have about 10,000 screens open, so bear with me for just one moment to see if I can get the right screen up. Can everyone see the deck?
Okay. Yep, we can see it.
Great. So hopping a little bit into our story. So Skai is our vehicle. And as mentioned in the video, clearly we're using hydrogen fuel cells as the main source of energy here. As a result of this, we're clearly increasing efficiency, we're lowering costs, and besides that, I mean, the emissions are literally water. What we're doing right now is testing all of our capabilities under the FAA watch in all of our certification teams. So we have all of those plans in place. Like competition, we have the same amount of payload, and we can go 4, if not potentially 5 passengers plus the pilot right now. a little bit different than some of the other competition is how we can reconfigure the space depending upon the usage and deployment of the end user. The approach that we're going to take is sell the vehicles where we're going to be the Boeing, we're not going to be the Ubers of the Sky. You'll see in the slides later, our goal is to increase the either revenue line items or TAMs of those end users to get into additional types of services they may not have been able to get into with their current offerings today. The initial Sky will be able to get up to a 200-mile range, and that's covering all of the safety precautions of FAA with the reserved and everything else. We will be able to increase that dramatically. The goal is on this current design for this footprint to get up to 400 miles, but that will not be on the first SKUs out the door. As mentioned, and Jeff is on the call as well too, we have 6 fixed rotors. Some of this is the simplicity that we're able to have with the design of our vehicle. Speeds right now, the average cruising speed will probably be somewhere in the plus or minus 100 miles per hour. But the beauty of our vehicle, unlike competition's roughly 1 hour full battery charge, we will be able to have full fueling done in 10 minutes or less. So carrying forward with the range aspect, clearly we have the stronger range capability. The economics of our system as well too is a reduction of the capital and then the operational and maintenance costs. For example, some of competition out there has the 12 rotors and we have 6. So just to put this as a tangible example, to replace the rotor of our vehicle compared to others is going to be about the same amount of time. The average time that we're studying right now is probably about 11 hours. Most of that is the paperwork to stay compliant with the FAA process and certification. So although it's the same amount of time, we have half of the amount of rotors as competition. So we will be able to be more airworthy with less downtime simply on some of this simple maintenance of just the rotor, for example. There's obviously many support systems, government systems, both in the US and outside as well too. Right now there's, the European Commission as well as, the US Commission, there's hydrogen fuel hubs going up as well as major incentives and tax credits that we see starting up, and I'm sure they will continue to keep advancing. And then we're also able to do on-site fueling, or in the site where we don't have the on-site, we can simply have more of the conventional type of fueling of a vehicle today with simply the delivery trucks being able to meet us where we are. We are able to use existing infra right now. The footprint of our vehicle is slightly less than the typical Bell right now. So we will be able to use current infra, and we don't have some of the constraints of the 50-foot wingspan that other vehicles do have as they need to both put the batteries as well as be able to extend their range. And then clearly we have the greenest option right now in the AAM market. Right now, it's estimated that the electricity is still about 60% fossil fuel driven. And then this number is only going to drop to probably about 38% or so by 2035. And this is all a part of the Energy Information and Admin, which is part of the DOE. So in our work where some of our decisions have come from, you can clearly see the expansion of range, which then puts the great word of options in play for those end users. So with those additional routes, you can do many more things with it, and we'll be able to expand anything addressable in that AAM market with the use of hydrogen as opposed to the electric and battery options. We will also be able to make runs without needing infra on the other end. So for example, there's a bunch of companies right now, you'll see them out there, the Beta, the Archers, the Jovies, that are trying to get additional support in there for their infra, which is going to take a tremendous amount of time, energy, resources, and everything else, where there's municipalities right now, we'll say, for example, in Connecticut, where they can't get proper zoning and approvals for schools to be built. So I'm pretty certain that some of the infra will fall behind the educational types of systems. So it's very difficult for some of these vehicles to be able to be commissioned quickly, where we can get running much quicker. Again, given some of the decisions that we've made with the fuel source. The return on the invested capital will obviously be a bit increased, and we'll be able to have a lot better turnaround times where we can make multiple runs, like we said, for example, of possibly going Boston and New York and back. So it's very exciting from that aspect. When we get into a little bit more of the costs of hydrogen, as we said before, there's major incentives right now going on out there with the hydrogen hubs invested in the U.S. right now. I know one wasn't up in the Northeast, but we can run many different simulations and modeling, which we have been doing right now. And there's also many other European incentives there as well. Right now, PwC is expecting that the hydrogen production costs are going to decrease roughly by 50% by 2030, and then even continue to fall at a slower rate all the way out through 2050. Right now, with the modeling that we do have, our TCO models are coming in still under the current pricing of hydrogen, still coming under the Bell helicopter traditional model, as well as some of the electric competition out there now. When we drop to the new pricing of hydrogen, we anticipate that we'll be able to drop probably another 20% lower than other vehicles that can have more of a limited capacity as opposed to our Skai model. There's also the Inflation Reduction Acts and clean hydrogen production tax credits, which will give credits up to about $3 per kilogram as well. And then the European Commission has a little bit different type of program. It's more of a fixed premium. But again, you can see that people are investing into hydrogen. It's something that's come out in, highly spoken about in, the American Science magazines back in the 60s. And with Andy's showing of many companies and, the trucks out there, 50,000 plus. So Walmart is a big user of it. If you actually put a satellite map of the U.S., you will be able to identify all of the hubs out there right now. And there are far more than one would imagine. So other parts right now is that the end-to-end transportation system right now, the hydrogen is clearly the cleanest aspect here. There's different types of modeling out there as well now, which are showing that you can build full end-to-end hydrogen fueling stations of varying capacities depending upon what's needed, starting as low as $2 to $3 million. It's very easy to have a hydrogen station. We have one at the airport we're currently using right now. We were able to install that very, very easily with all the safety and precaution pieces in there. Clearly, I mean, the emission is the pure water. The fuel cells are very long lasting as opposed to the batteries right now, where even though these new batteries are advancing very, very quickly, they're still the same cells used right now in the EVs. And with the modeling, most likely these batteries in other vehicles are going to have to be swapped out a couple of times a year. We right now think that the fuel cells could potentially last as long as the airframes in our vehicles. Then when we get into the recyclable aspects and reusable aspects of the cells compared to the batteries, very different there as well too. So there's many precious metals and things like that within the fuel cells, and that's about 95% or so, and the rest can then be recycled conventionally, whereas it's a little bit different with the battery packs. The battery packs also now, due to the EVs and other types of markets through Bloomberg, has seen most of their price declines already because of the economies of scale have already really been realized. and the fuel cells aren't there yet. So this is another hedge that we have, that the fuel cell productions will decrease slightly as well. So just another visual here is to show a potential example with partners that we're working with right now in Massport and Mass, as well as Fed DOTs. So in a classic business travel type of an example, if you're leaving Worcester to go to Boston around 7 in the morning, it's going to be at least a 2-hour drive. The average business work trip is about 3 days, and no matter if you're driving or not, if you're going Uber or with your own car, it's still the same amount of time. Right now, if you were to replace that out with our vehicle at a 3-seat fill rate of Skai, you will be able to be profitable at only a 2.4x ride share compared to the Uber today. And when we drop that hydrogen by another 50% or so, that number could drop down to about a 1.8x, if not even a little bit lower. So clearly, for some corporate travel and things like that, this is going to be a very viable solution. For the changing of placement and things like that, for the big G5s and other aspects of vehicles, this is another no carbon footprint for the repositioning and having to upcycle these bigger, much more expensive aircraft, where we can just get there much quicker without even having the carbon footprint and the buzz for the corporate Americas, high net worth individuals, things like that as well, which is just one potential deployment of the vehicle. We can also do other aspects of, another example is Martha's Vineyard. You can see the amount of time in savings, and the example here is with Cape Air, and that's going to be when Cape Air is even up and running. So we can be extremely flexible, and we just want to make sure that we present the most available options in order to expand the potential business models of those end users that we're speaking with today. So clearly, right now, we're designed to work in this airspace. We can deploy this in multiple types of routes and fashions, remotely and or not. We will be able to have this market in intercity, urban, however you speak, because of that range and because of how quiet this vehicle truly is. And those are things that people will not be able to understand the noise until they truly see this vehicle. It's truly amazing. And then with all of these new opportunities, the significant reduction in capital and operating costs that we deliver in any of these types of models are apparent. We will be able to, now from the business standpoint, even off the get-go, be able to sell these at a profitable, healthy margin. And in that, we'll be able to help those end users penetrate this into their modeling quickly. The market is clearly there. We are in with multiple analysts at this point in time, and we clearly have the market there. I don't think we need to do any convincing of that. So I know this is just a very small snippet of Alaka'i. We wanted to just give you a little idea of where we were, clearly some of the reasons as to why we have chosen hydrogen, and want to hand it back over to either other members of the team or back to Andy for any of the Q&A. Thank you, everyone.
Outstanding. Oh, that was just excellent. I love it. And yes, we'd like to hear questions. I'll throw out a few if I don't see any hands up. Let me open up my screen here. There we go. So I can see. Feel free to put up a hand. Patrick, I see you've got a question. Floor is yours. And I think you might be on mute, Patrick.
Of course. Sorry about that. Hey, yep, Pat Host, freelance news reporter. Wondering if Alaka'i is still participating in that NASA hydrogen project, and if you could perhaps give us an update on that, if that's correct.
So yes, as far as I'm aware, we're still working very closely with NASA. I am not the one to share those project details. I can clearly get you in touch with project managers of that in order to have the proper updates there, not to push you in the wrong direction.
Thanks, Tim.
Sure.
And feel free to put a hand up if you have a question. I had a quick one, Tim. You mentioned that it doesn't take an act of Congress to have a tank installed, a hydrogen tank at one of your new customers' airport. In the interim, while they're working on that, can they just park a tanker truck there, a hydrogen tanker truck to fuel?
So from what I've heard right now is that we can clearly have that delivery of the hydrogen in that method. What we do is we actually source ours differently and actually have our individual fueling station filled on call when needed. In the very early stages, we would fill differently, but from some of the things that I've heard down the line, when these are in use, we will, if there's no infra on a certain end or it had to be landed for certain reasons, we will be able to have the conventional fueling done like they are at the airports today. It's a simple, plug hose in, snap once, twice, and it's all very, very safe and contained.
Okay, excellent. And Michael Duke, you can unmute and we'd love to hear from you.
You mentioned a 4-hour flight time. That's awesome. Congratulations. I am concerned though, as a passenger, have you done any studies or is there any data on passengers over 2 hours without a lavatory? 4 hours just seems like a long flight.
Yeah, I think this is more the business case of we don't need the infra on all touchdowns, where we can be able to make a couple of hops and not need that in place. Sure, we could certainly do, longer flights, but I think that would be a little bit further down our technology roadmap and our product roadmap in order to clearly keep all aspects of passenger safety in interest. So no, we haven't done extensive research on one way. It's more so how will we be able to do that, which I know the engineering teams do have those answers to some of those solutions now. Just to put a small example out there with the aspect of hydrogen being so light, with a simple 3.5-inch increase to our radius of any fuel tank, that will double the volume of that tank. So simple things like that, again, depending upon the configuration of the vehicle, if it's going to be a mid-flight or something where we don't need the seats or the payload aspect capacity, we can get there in many different ways.
It's certainly nice to have the additional reserves if you need them for an alternate airport, or if you need to go out around weather. Even if you're only intending to go 2 hours, boy, having an extra 2 is a wonderful thing as a pilot.
Sure.
Mike Francis, would you like to unmute and fire away with your question?
Yeah, thanks. Way in the back of my little pea brain, I recall something about that it takes more energy to create hydrogen, which outweighs the benefits of it coming out the back of the tailpipe. That may be outdated. Wonder if you could update my little pea brain on that.
Jeff, do you want to take that one?
Yeah, it's that's part of the infrastructure. In terms of what we're dealing with in the end user, we see the benefits at the end user piece, and we see a lot of advantages and a lot of advancements to be made in terms of the making of
it. Something that I can add, Mike, is that we're at a place in many geographies where we're actually, in some times of day, we've got overcapacity on green energy. So if you have, for example, a windy day in Texas with plenty of sun, they're just turning off windmills. There's no place to put it. They have some days when they just got nothing. But right now, There are geographic areas where there's no place for it to go, and it's like fluid. If you don't have a bucket to put it in, it's just going on the floor and you're wasting it. So they're turning off windmills. One solution can be to have these mobile electrolyzers, even in a truck or a container, a shipping container, park it next to a windmill, and then just flip the switch. You don't need that electricity for the grid. Great. You got a big bucket of water, just start using that. And that's, in that scenario, that's free electricity that you're then capturing that unused electricity, converting it to the water to hydrogen and using that as a battery. Eric Schiff, could you unmute and ask us your question, sir?
Yes, I can. So 2 quick questions. First, thanks, Tim. This was very informative. You mentioned a couple different markets. I was wondering if the first question is if you could maybe clarify which you expect will be the first market you'll launch in among the ones you've mentioned. And the second is, in terms of hydrogen production, just to hear your perspective about, you or your colleagues' perspective about how you expect that to progress between, green versus blue versus gray, et cetera, over time. Obviously, a lot of hydrogen today is not currently generated through clean mechanisms. Thank you.
Sure. Yeah, so as the video had alluded to, we can reconfigure the vehicle quite easily. We're in working discussions right now for air taxi. We're in working conversations right now for cargo aspects, delivery services, where simply the little larger drones right now can't do it. Even though there's a quote unquote 50-pound payload that they could have, the slightest bit of breeze is going to take them offline for the day. And that's where we hear there's a lot of issues right now with those, even mid-sized to larger drones. We are also in heavy discussions with some medical aspects of med flighting, of organ transport, of medical transport, as well as specimen types of things, where in congested areas, such as one of the case studies we're working on right now, where people may not think it would be an issue, is actually Portland, Oregon. So with the highways there and the rivers and simply 2 bridges, 12 miles can take up to an hour to 2 hours. So if you have a life, a shelf life of a specimen and it doesn't hit, that next day you may have to do another 100 draws kind of thing, which gets extremely expensive. So right now what we're doing is building case models for this individual company, where not only will they be able to add on this new service outside of what they're doing right now in van delivery, but they'll be able to add on higher net worth types of relays and services, as well as picking up additional stops. So right now they have contracts right now across the U.S. for the VA. So that's one aspect that we could have. So in terms of the one that would go out first, I can't really say exactly where, but we also have in which could be a little less and or more constraining in some of the branches of the military as well too. If they can get rid of the hydrazine aspect, I'm sure they would. So that answers that. Right now, I mean, clearly we're shooting for the green hydrogen. Right now, we source ours as green hydrogen up near the Canada border. I don't have a ton of insight in terms of overlapping when we think we can get more, to the proper color of green opposed to the others. But that's clearly our goal. And the goal of what we're going to be able to do is almost to have a full ecosystem, which is, kind of leaking a little bit more. But with the production of what we can do with some of these solar and wind and other natural elements here, we should be able to quickly get the capacity necessary as, again, another business case for these end users to at least let them think about how they want to have their ends. But we certainly will make sure that at the vehicle sell-off, we'll say, that they have ends to source hydrogen with our contacts in the network.
Thank you, Tim.
Something I think about along those lines is that electricity from the grid isn't necessarily green, but it's becoming greener. And we as organizations or individuals have the option to source green if that's what we want to do. So I've got 35 commercial solar panels on my roof. You know, the grid where I am is you know, it's 50-50. I know we're burning some trash to create electricity, but my solar panels create more juice than I need for 2 electric cars in my whole house. And that's, I think, a decision that corporations are going to be able to make as well. And they will be making that more and more as this becomes more important. We've got about 5 minutes left, and Hazel, I see you have your hand up. Could you unmute and ask us your question?
Yeah, sure. So thank you so much for sharing that. It's very interesting. And actually, this question isn't sort of, I guess, hydrogen specific, but just in general. As we know, you know, the airlines operators are very sensitive. They've got very thin margins as it is. I'm curious in general what the strategy is around luggage and other cargo that's accompanying the passengers. So if you're just doing New York to Boston for a meeting and you've got your laptop in your backpack, you're fine. If you're doing London to Berlin and it's a 3-day conference, you've likely got, you know, carry-on and luggage. And by the time you've got 2 cases on, that's one paying, you know, passenger that you've taken up from a payload perspective. What's the strategy there? How are you sort of thinking about that? I'd love to hear your thoughts on that.
Sure. Yeah. I mean, so some of the initial designs that we have now on the marketing model, we made sure that in the quote unquote trunk of the vehicle that you can fit your golf clubs. So it's not the fishing poles, which I would have been a little bit more, you know, partial to that, but there will be space in that trunk. Also, a big thing that you'll be able to see actually in some of the pictures that were in that deck, it was very important for us to have the feel when you walk into the vehicle that it feels like you're walking into a 4-star hotel. And so it's supposed to be made as spacious as possible. And even though the configuration of the seating is different between, we'll say, the 2 rows in the current configuration, it will fit 2 250-pound individuals very comfortably. So that's not going to be the average. We'll be able to have, you know, plenty of leg room, like a, you know, larger SUV, where even between the seats and things like that, you should be able to fit reasonable types of items. It's not going to be a very small, you know, setting. You know, when and if you see us at some shows and you sit in the vehicle, you will be pleasantly surprised with the amount of room and comfort you feel. And so again, depending upon the final form and fit with the FAA as well too, we'll be able to address that a little bit better at that point in time. But leg room, shoulder room, things like that, you should be able to fit more than you would expect.
Tim, I'd like to put in a request for some exterior ski racks.
Yeah, I totally agree with that as well too.
We have about 90 seconds left, and Patrick, I see you have a question. Will you unmute and finish out this excellent session for us?
Yeah. Hi there. Wondering what FAR part you're certifying the Skai under, and perhaps what's your strategy for certifying the aircraft?
Yep, I can take this one. So it's going to be under the powered lift category, but we're a subsection of that. The Joby issue paper that just got posted recently, that final ruling, we will be a little bit different than that. We're projecting that we're around 80% similar to that powered lift category. However, we're defining our aircraft as a special class rotorcraft. Flies a lot more like a rotorcraft, no rotating rotors, or no rotating propellers, I guess. So it's going to be a mixture of 23 and 27.
Do you have perhaps a deadline or a timeline for when you want to be certified for flight?
Yes, 2026.
Awesome. Hey, thank you so much.
Got it.
Great questions, Patrick. I want to wind things up by thanking Tim, Jeff, and Andrew and their entire teams for being here today and for just doing some great work on what's going to be a super exciting aircraft and a very positive impact on the environment and our transportation capabilities. So thank you all, gentlemen.
Very welcome. Thank you, Andy. Thank you, everybody.
Thank you, Andy.
Thanks all. Thanks everyone for being here.
Thanks, everyone.
And we'll be posting this video in the next week or two on the website, and I'll send you all a note about that.